says, since your calculator has every possible, ask your parents. Some of them might not remember their math classes at all. So this might be ask them and they have no memory of it. But a lot of your parents would have had, I'm trying to find, on old textbooks before people had scientific calculators readily available. Okay? Scientific calculators. When I was in high school, you could get a scientific calculator, but a lot of textbooks still had at the back of the book a list of the tan ratios. I have a couple books here. Let's see, what would be this one's logarithmic tables. You used to get, oh yeah, it's in here. There used to be books that you would buy instead of having a calculator. See, there's just numbers like crazy in this book. And in this book, it has tangent, and then you could find out what tangent of 45 was by getting to the tangent category. Hello, welcome to class. If I was going to use a letter to label that side, sometimes you'd like to use like a little X, right? Because that's a common letter that you use. But in this case, what letter should I use? Because this is capital Z, we label the opposite side with a little z. According to TOA, we have an angle of 70 degrees here. So I can write the definition of tan. According to the definition, tan of 70 degrees is equal to something over something. Opposite side over adjacent side. But now you have to tell me which is the opposite side, which is the adjacent side. And it changes depending on which angle you're looking at. We're looking at the angle of 70 degrees. Is 5 opposite? Is Z opposite? Is this side the opposite side? Z is opposite, so we would put a Z on the top. Which one is the adjacent side? Well, adjacent means right beside, but this side is right beside and this side is right beside. Which is the right beside one? Whew. One is a little z, this is a capital Z, as you can tell so easily from. Probably the letter Z wasn't the best one to choose for seeing big and little letters. Okay? Does it make sense that Z to X is the hypotenuse? So then the adjacent side would be the 5. Now, I said earlier, while I was muted, that your calculator has everything stored in there, every single number. So when I go to my calculator, if I type in tan of 70, slowly, with very fast technology, and I push enter, like this, maybe. There it is. Yes. Did I push enter? I get 2.747477419. Your calculator has it memorized that if you take the opposite side and divide by the adjacent side, it should equal 2.7477 dot, dot, dot. If your number is different, you might be in radians. Yes. So we're going to hit the mode button and change it to degrees. We use radians in grade 12. Now you can try it. So we need to find, okay, we need to find a z that makes this work out. Like if I try 12, 12 divided, like guessing, oh, I'm 2.4, I'm not there yet. Right? 13 divided by 5, is it 13? I'm getting closer. Now, we don't want to guess and check like this over and over again. We can use our algebra. Our algebra says, if I want to get this all by itself, I times both sides by 5. So I could times this side by 5 and this side by 5. That would technically cancel out on the right-hand side, and I would just get z is equal to 5 times tan 70. So I could have taken the 2.74 and times it by 5. Mathematically, I'm going to just type this in all at once, 5 times tan of 70, and push enter. And I find out, oh, I was close when I got to 13, but the actual answer is 13.74. But it says round to the nearest tenth, so I would write 13.7. Do I have units? Yes. Centimeters. Circle my final answer. And because we have this stored into our calculator, it helps us solve it. Okay? Here is in the first house that I ever owned, the shingles needed to be replaced. And I decided I was going to do that with some friends, so I needed to go buy some new shingles. If we draw a picture of what I had is, here's my, it was just a pretty simple house. It looked like this, and the shingles would go on here like so, okay? So I needed to find the surface area of this to find out how many shingles I needed to buy. What could I do? Okay? I could have climbed up on my roof, but it was kind of steep, and I didn't want to really fall off of it. I could have climbed up on my roof and taken a measuring tape and measured this and measured this. I could also, on the ground, measure this instead of climbing up on the roof. Does that make sense? That I could get this side by just measuring the ground on that side. But this I was having a little bit of trouble with because I didn't want to go up on my roof because it was steep. So instead, what I did is I measured this length here, and then I went up to the roof and took a piece of paper and I figured out what that angle was. I went down on the ground and I measured that angle, and I found out that that angle was, I think it was 40 degrees or something like that. I figured out this length was 8. I had the 40 degrees, and then I could use the trigonometry, because trigonometry, just like we did in this one, if you know an angle and one of the sides in a right angle triangle, you're going to be able to figure out the other ones. Which one could we figure out? Well, using tan, we figured out z. We now know that z was 13.7. Can you see that if you wanted to find the hypotenuse, you could now do a squared plus b squared equals c squared? Right? And now we found all the sides. If I wanted to find the other angle, I could do that as well. Because angles add up to 180. So if you know one angle and one side of a right angle triangle, you're going to be able to figure out everything in that triangle. And all of the values of the angles are already built into your calculator. So, determine the length of VW. Okay, what letter would I use for VW? An X, because this is capital X, so we would use a little x. Get better letters. Yeah, this is W. This side would be little w. I'll make it a little rounded. The little w is rounded, the big W is sharp, right? Okay? So the only thing we've learned so far is TOA, the tan ratio. The tan ratio says that if I know 42 degrees, tan of 42 degrees is equal to opposite side divided by adjacent side. Does it make sense that the x is your hypotenuse? Because whatever is opposite of your 90 degrees is always your hypotenuse. So if I'm using 42, do I use W or 7.2 for the opposite? Right, here's the 42. Straight across that is my opposite. And my adjacent is not the x, because the x is the hypotenuse, so sometimes it's going to be the W. This question's a little bit harder because the W is on the bottom. Once again, your calculator hasn't memorized what tan of 42 is. It's 0.900. We need this to equal 0.9. In other words, you wrote a quiz and you got 7.2 and you ended up getting 90%. What was the quiz out of? If you wrote a quiz and you got 90% and you scored 7.2 on it, what was it out of in total? Okay? 8? Let's check it out. 7.2 out of 8. How close are we? 7.2 divided by 8. Is that a good guess? Phenomenal guess. Okay? So by our guessing, we actually guessed W to be 8 really quick. Now, we don't want to guess. We want to use our algebra skills. So now, we know that this is 90% or 0.9. 7.2 over W. If the W is on the bottom and you want to solve, like our goal is to get W equals. That W, when it's equal to something all by itself on one side, isn't on the bottom of a fraction. So our first step is how do we get rid of something on the bottom of a fraction? What's the opposite of dividing? Multiply. So I'm going to multiply both sides by W. That would cancel out the W's on this side. But it doesn't get W by itself. Now, on the left-hand side, do you see that I have W times tan of 42? So what's the opposite of timesing by tan of 42? Divide. Oops, I'll go back to black. W, we divide both sides by tan of 42, so I'd have 7.2 divided by tan of 42. Go to my calculator. 7.2 divided by tan of 42. Enter. 7.996. That's the algebra way of figuring out that W has to be 8. So I can write on my diagram that I now know that W equals 8. Well, that's rounded, but pretty close to 8. How would we find x? A squared plus b squared equals c squared. So now I can write 7.2 squared plus 8 squared equals x squared. Now technically, if I was going to my calculator, this is what I would do. I would do 7.2 squared plus, and then I would use that answer with all of its decimal places. So either I would retype it on my calculator. I have an answer button, which just says reuse the answer you had from before. I'd square that one, push enter, and I get that x squared is 115.78. What's the opposite of squaring? Square rooting. I square root that answer. So what I did here is I didn't round until I get to my final answer, 10.76. I'm going to reread my question to see if it said round to something, to the nearest tenth. So x will be 10.8. I checked my units. There's my final answer. So again, you often need to reread a question at the end to make sure you find out how you're supposed to round, what your units are, and have that all included. You could, but let's say I wanted it accurate to more decimal places. If you did the guessing and you got close, your final answer might come out to 10.7. Then you would lose a half a mark because you're not accurate. Okay? So we do, the algebra way is, in my opinion, faster. Okay? Because it always works, and it's like this one was a little bit harder because you had to do 2 steps, right? With the W on the bottom, you first had to multiply by W to make sure the W wasn't on the bottom anymore, but then you had to divide by tan of 42 after that to get W all by itself on the top, right? The W needed to be all by itself, not a, right now the W is on the bottom, so if you got rid of the 7.2, the W is still on the bottom. You'd have 1 over W left on that side, and then you still haven't solved for W. Yeah, so what this is what we want to get alone, the W. Right now the W is problematic because it's on the bottom of a fraction. So I multiplied both sides to get the W on the top, but it's not alone, it's with the tan 42. Then I had to divide by tan 42 to get happy W all by itself. All right? That's your basic grade 9 solving equation stuff, right? That comes up over and over again in grade 10. Okay. At a horizontal distance of 200 meters from the base of an observation tower, the angle between the ground to the line of sight to the top of the tower is 8%. One of the things that you're going to have to be able to do in this unit is read and interpret what that means. So in reading this question, I have an observation tower and something is 200 meters from that. I would like to draw a diagram. Here's my tower. Oh yeah, use your art skills. Maybe I'll put a window up here. Somebody's hair coming out. Okay. And 200 meters away from that tower, or maybe make it like a castle tower. There we go. Oh, 3 dimensions now. Look at me go. There we go. There's a little guy. There's a little guy up here with a bow and arrow protecting The princess. Okay. So 200 meters away from the tower, the line of sight, the angle between the ground and the top of the tower is 8 degrees. Does it make sense that this would be the 8 degrees there? Line of sight means there's not actually a line drawn to the tower, but your line of sight is if you looked and had like laser Superman eyes and, oh, I like that. Send that laser right to the top of the tower. The angle between the ground and that line of sight is 8 degrees. And with just this little bit of information, we can tell how tall the tower is. Why? Well, TOA, we've got our definition for tangent. Tangent said, tangent of the 8 degrees is the opposite side over the over the adjacent side. Are you in agreement that the laser beam eyesight thing is the hypotenuse? Because the tower would go straight up in the air. That's your 90-degree angle. So then, where will I put, what will I put on the top of my fraction? What will I put on the bottom? X and 200 on the bottom. Because X is directly opposite the 8 degrees. And the 200 is the adjacent side. That's not the hypotenuse. Yeah. So you would multiply both sides by 200 and this side by 200. That would cancel out the 200s, giving your X, which we wanted all by itself. Your calculator has tan of 8 memorized. So we can just go 200 times tan of 8, 28.11 to the nearest meter. 28 meters. Starting to come? Okay? And so we get to a homework assignment and our first project. So I'm going to introduce to you the project. I hope you can see here. Yes, Ben? Oh, okay. So, our project, our first project. You're going to need your textbook, because on page 84 of your textbook, it describes how to make a clinometer. Let's see if I have mine. Oh. Yeah, this will be due next week.
Not confident with this at all, but
All right, but at least it's not the end of the world, right? No. Okay. Mmm. Oh. There we go. I'm unmuted again. There we go. So, you're going to make a clinometer according to the instructions. You'll need a piece of string, a straw, and a weight. When you look through your straw, the string will fall down, and if I looked right here at an object, it's right at the 50 degrees. That would tell me, because the string is holding down and measuring this angle, if I got 50 degrees, it would tell me this is 50 degrees there. This is 90 degrees because the flagpole is straight up in the air. And adding up to 180 would tell me that that's 40 degrees. You're going to need to get a measuring tape of some sort. Ask your parents if they have a measuring tape. You're going to measure how far away you're standing from the flagpole. So let's say you measure from here to here, and your measuring tape has feet, and you ended up standing 10 feet away. Does it make sense then that this line is also 10 feet? And you could figure out the opposite side using tangent. What do you also need to measure? You need to measure how high your eye is above the ground. Because when I use my eye and measure the angle to be 40 degrees, I will only get this height to the top of the flagpole. And then I'd have to add my eye height. So you measure how tall it is from the ground to your eye height. Then you're going to use trigonometry and your clinometer to figure out the height of the flagpole. There's going to be some error. Some people get a little bit different because the ground isn't the flattest there. You have to try and find the flattest point to measure it. Measure it with your eye. Okay? And then part 2 of your project. So in your poster project, your poster is going to have part 1, which will have a picture of a flagpole, have a picture of you as a stick person maybe measuring, or maybe like want to graphic arts it, like actually snap a picture of yourself and cut yourself out and put you on there. However, okay, you're going to show the angle that you're going to get. This isn't actually that much work. There's some assignments you will get later in school that will make this assignment look like this isn't very much work. But it might seem like a lot of work in grade 10. Okay? Number 1, everybody does the flagpole. Number 2, you choose something else that you want to measure how tall it is. Something big. Maybe the height of the school. Maybe the height of an apartment block near your house. Right? Maybe you want to measure something else really tall. Like I've always wondered how tall that tree is. So again, what are you going to need to do? If you want to figure out the height of a very tall tree. Yes, just watch. Okay? This is the tree you want to measure. You take your measuring tape and you walk a certain distance away from the tree. Maybe you walk 15 feet away from the tree. You're standing right here with your wonderful big blue eyeball. You take your clinometer and you look through the clinometer and it measures 50 degrees. So that would be 50 degrees there. That would make this 40 degrees and the tree at 90 degrees. The height you could figure out is not the total height of the tree, just this part. And then you have to add your eyeball height, to get the total height of the tree. Option number 2 is you lie on the ground and very hard try not to, but that would be very difficult. You're trying to find the height of the whole tree, so you'd have to add, you'd solve for this part, plus you have to add the part up to your eye to get it to be more accurate. This allows you to measure something that's high without having to climb it. You see what's happening? So for the flagpole part, you can follow the instructions on page 84. Okay? No, that would be too soon. Make a poster. I would start it this weekend. Make a poster to display your results. Your poster has to have your clinometer attached to it. Okay? I have to mute it for a second. Unmuted. There we go. That wasn't on the video. We're all good. It is worth 20 points. Math is 12 marks. Creativity, 4 marks. Neatness, 2 marks. Your clinometer is worth 2 marks. Okay? Let's put it up. It'll be due on Thursday because there's no school next week, Friday. You want to come in when there's no school to hand it in? You're not here on Thursday? Then you can hand it in on Wednesday.